about this last class. I did a measurement here using a ruler, and then I expressed that measurement using significant figures, right? And the discussion that we had was exactly this. These figures that we have here are digits, right? We are talking about significant digits in a number, right? That's what those figures are, right? So then we did that measurement. I don't remember exactly how much we measured, but it was something like this. We measured the length of a piece of wood using the ruler, and I got 22.65 centimeter. That's the best reading that I could do in that block with the ruler, right? And then what we discussed? We discussed that I was pretty sure about those three first digits, 22 centimeter. I'm sure that I have it. I could see 6 millimeters. Millimeters very small, but I could see 6. And then we have something else. So the block was a little bit ahead of the 6 millimeter, but it's hard to say what is the fraction of a millimeter that you have. So then this number here, this last digit is in reality some kind of a guess that I'm doing because I cannot see that fraction. A vendor could say, no, it's 3/10 of a millimeter, and this could be 22.63, right? If you think that is just 3/10 of a millimeter. But it's very small. I don't really know how much it is, but so you can see that when we express a measurement, so this is a number that express a measurement using significant digits. The last one is where the problem is, okay? So that's the idea about significant figures. So those other digits, they have much less chance or no chance to be wrong. But the first one, the last one, the 3 here in this case, eventually is where we have some problems with that number. This digit can be a 0 because sometimes if you have a ruler and you have here the 22, 1 millimeter, 2, 3, 4, a half, 1, 2, 3, 4, and then comes the 23. So what happens if the block ends up exactly in 6 millimeters like this? So I'm doing the measurements, and maybe I could approach this a little bit more to see a little bit better. Okay, so we can see that the block ends up exactly in 6. I don't have a fraction of the next millimeter. So how I'm going to express this? We are going to express this as 22.60 centimeter, right? So if I can see that the object is exactly on the mark, I call that 60, right? But one thing that we discussed last class is that, we still can use rulers to measure things, right? But today we have devices to measure distance, right? We have a caliper, right? So a caliper to measure the diameter of this pen, I just put it here, and I can see on the display 4 significant figures in millimeters, right? So this guy here can give me a 1/10 of a millimeter. He knows it, but the problem is in the hundreds of millimeters. So that's the caliper, right? The next one would be the micrometer. So the micrometer or the micrometer is normally used to measure very small thing. I just put the object here in between and turn this, and then I can see the digits here. And this one can give me 4 sig figs again, but 3 decimals in millimeter, right? So the micrometer can give me 3 decimals in millimeter. It means that the error of the micrometer is in 1,000 of a meter, or 1,000 of a millimeter, or 1 million of a meter, right? So this is 1 micrometer. Micro is 10 minus 6. So 10 minus 6 of a meter, or 1,000 of a millimeter. That's the limit of the micrometer. So it can be 10 times better than the caliper, and the caliper is 10 times better than the ruler. So I can use different apparatus and get more and more decimals here. Okay, and this is something very interesting in science, because in science we never know anything 100%. It depends on what apparatus you are going to use. Eventually you can have more decimals, but we always are going to have some limitation in what we know. So let me close this. So we always going to have some limitation about what we know, because our apparatus, they always have some kind of a limit, and we can go further in decimals until some point, and then we hit the limit of the apparatus, right? So that's the idea behind significant figures. Okay, so if the object ends up exactly on the mark, I put a 0 on that unknown next digit, right? Because it ends up exactly on the smaller mark of the apparatus. But it's what I said, if we use a caliper or if we use a micrometer, you just read the display and you have the significant figures that the apparatus can give you. You don't have to keep wondering what to do, right? And today, calipers and micrometers, they are very inexpensive. 20 bucks, you can buy one digital caliper or micrometer. So they are very easy to have, right? Okay, so the next thing is how we are going to put numbers together with different numbers of sig figs, right? I'm going to give you a practical example. I'm going to add some numbers first, because eventually some of you guys already know that when we add or subtract, right, we look for the decimals and not for the number of sig figs of the numbers, of the terms, right? Why is that? I'm going to explain why. So let's assume that we are adding 1.5 plus 2.6748 and 20.23. So let's assume that I'm adding those three measurements. These are all significant digits. Somebody used different apparatuses. So we can see here 1/10,000 in this number. The last decimal is 1 in 10,000. So I don't know what kind of apparatus it is. I don't know the units, if it's in centimeter or in millimeter. It doesn't matter. But let's assume that this guy wants to add those three numbers, and they have different numbers of sig figs. So this one is 2 sig figs. This one is 5 sig figs. And this one here is 4 sig figs. We just add the numbers. We got the 8, we got the 4, we got the 0, we got the 4, we got the 4, and we got the 2. And then I got this number here, adding those three numbers. So at this point, you just use your calculator, add those three numbers, and you have this result. And then comes the question, where I'm going to stop? How many significant figures I have here, right? Once that those ones are different, the terms, this one has 2, there has 5, there's 4. So the explanation is very logical, right? Why we consider decimals. Look, this is a treble digit, this is a treble digit, this is a treble digit, right? So 1.5 with only 2 sig figs, what happens? The guy is sure about the 1, but he is not sure about the 5. This guy here was sure about those 4 digits, but the last one, treble again. This one is the 3. So when I add, what's the first one treble down there? Well, the first one treble is the 4. Is being affected by that 5, right? At least. Because eventually you can affect a little bit that 1 too, because if it is more than 10, it's going to affect this one. But in terms of decimals, I'm sure that the minimum, this one here, is going to be affected. The first decimal. Because this one here, this decimal is treble, is going to reflect on this one here on the 4, right? So I'm supposed to stop here because all the other ones that comes after that, if this one is already unknown, right? I already have some problems with the 4. What I'm going to say about the other ones? So I'm supposed to stop here, right? Let me see here. Right. Okay. Okay, so if this one is the first one, I'm supposed to stop here. And what do I do with the other digits? I just throw them out? Well, at this point here, we use something that is called a rounding technique. And that rounding technique is very simple in order for you to consider the other digits that come after the 4, right? So if the next digit is bigger or equal 5, what we do? We add 1 to the last digit. So add 1 to the last digit. So if this 0 here was a 5 or a 7 or a 9, I would put this number here 5. And then the rounding is done. Right? But if the number is less than 5, what happens? I keep the digit. Right? I keep the 4. So very simple, the rounding technique. So because I have a 0, I'm supposed to keep the 4. So what's my result here? 24.4. Right? So that is the result. And then, shocking result. This is 3 sig figs. Is not 2, is not 5, is not 4 sig figs. Right? So you can see that the number of sig figs that I got as a result of this, following this logic about the first decimal being affected when I added those terms, right? The number of sig figs that I got has nothing to do with the number of sig figs of the terms, right? But it has to do with the first decimal being affected, right? So then we say that the rule for addition is that the number of sig figs that we're going to have here depends on the decimals. Do not depend on the number of sig figs, right? So I'm going to take a look at the least number of decimals of the terms, right? The least number of decimals of the terms that I'm adding, right? The least number of decimals of the term. That is going to be the number of decimals on the result. And then it's going to define me how many sig figs I'm going to get after add those numbers, okay? Because the nature of subtraction, so when we subtract two numbers, we put them exactly again with the decimal point on the same line, you remember? So when we do subtraction, we always need to align the decimal points and then do the subtraction, right? So we have exactly the same nature of operation. So that is going to be the same rule for subtraction. Because the
Mr. Camilo?
Yes.
Quick question.
Luis, yeah.
So for the number of sig figs when you're adding and subtracting, I'm sorry, you're blocking the screen. I can't see it. There you go. So my understanding is that, so when you add all of the numbers together, you get the 24.4048, correct?
Yes, I added those three terms, yeah.
And then in order to determine the
What's
number,
the first? The question now is, what is the first decimal being affected by those terms?
because you only have two sig figs in the first number, correct?
Said, I'm just pointing out here that they have different numbers of sig figs, right? But that is not what I'm going to look here in order for me to get some logic reasoning about adding those three different numbers. The logical reasoning is what? what is the first digit to be in effect when I got the result? This number here has the first decimal unknown, or the guy is not sure. So then it's going to affect the first decimals down there. And that is what I'm supposed to stop, because that's the idea about significant figures, right? I'm going to write the numbers that I'm sure, and I'm going to write only the first one that I'm not sure. And that one is going to be affected by this 5, right? So what comes after that is worst, right? I already have problem here on the 4, right? And then I just disregard the others using the round technique. I got these results. And then finally, I count that I got 3 sig figs, okay? And I can see that the number of sig figs of this result has nothing to do with the number of sig figs of the 3 terms, right? So I use decimals to get the conclusion about how many decimals I'm going to put in my result. And finally, I can count how many sig figs I got, right? So eventually, when we do this, eventually, depends on the numbers that I'm adding here. I could have a 4 sig figs, or 3, or 2, okay, or other numbers of sig figs. Eventually, could coincide here. It could coincide with the number of sig figs of one of them. But this is not the point. The point here, I picked this example exactly to show you that the number of sig figs that I have here doesn't depend on the number of sig figs of the terms. You're not going to look for that. You're not, forget the number of sig figs of the terms when you are adding or subtracting. You need to look for the decimals, okay? The least number of decimals on the terms, right? Okay, what happens when we multiply numbers? Okay, so let's. So when we add and subtract, so when I add or subtract, we go for the least number of decimals of the terms. And what happens when I multiply? We can see that when we multiply, the things change a lot. I'm going to put another example here and see what happens. I have 7.456. I'm going to multiply this by 4.32. I'm just going to write down here the multiplication. So how we do this? We take the 2, multiply by all this, put it here, right? So this is 21914. Obvious that you're not going to do that. You're going to use your calculator. But I'm just explaining what is the nature of the operation, multiplication, right? So then I take the 3, multiply there. I got here an 8. I got a 6, a 3, a 2, and a 2. And then I multiply by 4. I got here 4, 2, 8, 9, 2. And then what we do? We add those terms, right? I have here 2, 9, 9 again, 0, 2, 2, 3. And then I count the decimals, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So that's the result that I got. I got 32.20992. Okay, so that is how we multiply numbers, right? We take each one of them and the power of 10 that they represent, multiply by this number, and then finally I add the numbers and find the decimal point. Doing this operation with integer numbers is easy to explain how the multiplication works, but it works fine with decimals too, right? So this is the result that I got here, and then comes the question. How many? I'm going to look for decimals again. I'm going to look for sig figs. What I'm going to do now? Well, let's do the same thing that we did when we add and multiply and see about the logic, the understanding of what I'm doing, right? Look at this. if I have here 4 sig figs, so the guy that present this number, I'm assuming that the guy present this with the right the number of sig figs. So if this is 4 sig figs, what happens with this 6 here? The guy is not sure about the 6, right? What happens with the 2? So this is 3 sig figs, and this last digit, the guy is not sure about that too, right? What happens when you take a number that you are not sure and multiply by this entire line and put it here? I have an entire line of trouble digits, right? Because all those digits here in this operation was obtained taking a number that I do not know exactly how much it is, multiplying here and put all in here. So I'm not sure about all those numbers, right? Because they were obtained through this multiplication with a number 2 that I'm not sure about, and I put them here. And then if you think about the 6, when I take the 3 times the 6, this 8 here eventually is being affected too, right? When I take about the 4 times the 6, this 4 here eventually is not true, is not, there's a bigger error in it. And eventually I can be sure about the other ones, right? When I take the 3 here and multiply by the other digits, eventually those digits here can be correct, right? But the last one, I'm sure that is not, right? And then finally, when I add, what's going to happen? The first one being affected is this one here, is the 2, right? Because on the first line, I have the 1 that is affecting the first decimal of this here. So just using this kind of logical approach to the calculation, that I'm supposed to stop on the first one trouble, and assuming that it was affected this way, I'm supposed to stop on the 2 to write the result. I use the rounding, but the next digit is a 0. I keep the 2. What's the answer that I got here? 32.2, right? How many sig figs? 3 sig figs I got. But this logical process, thinking about trouble digits, right? But look at here, 3 sig figs, 3 sig figs. Is this a coincidence? No, it's not. If you do other multiplication with other numbers and exactly operate this way that I did here and look for the trouble digits when we add, you are going to see that the number of sig figs that you have on the result is the least number of sig figs of the terms that I multiply. Okay, so this is 4 sig figs, this is 3. What is the least of those 2 terms? It's 3. That's the number of sig figs of the result. Right? So we can see that when we multiply, the error spreads around the calculation, and the rule that we use for multiplication is different from the rule that we use for addition and subtraction. And because the nature of the operation of division, if I could do here the same thing with some dividing 2 numbers and showing what happens, but I can tell you that what happens in division is exactly the same thing that happens in multiplication. So because that, in multiplication and division, what is the rule for significant figures of the result? So I'm going to take the result with the least number of significant figures of the terms. Okay? The least number of sig figs of the terms. Just a second, guys. I got an email here real quick. Oh, okay. Okay. Not important. Okay, so in addition subtraction, I'm going to look decimals. When I multiply and divide it, I'm going to look for sig figs of the terms. Okay. I take the least number of sig figs when I have operations of multiplication and division. If I had to subtract, I go for the least number of decimals of the term. And then comes the next question. And what happens when I have a series of operations where I add, then I divide, and then I multiply some number, and then I subtract another number. So if I have this bunch of operations, one after another, what I'm going to consider for my results? You're going to consider least number of sig figs, because multiplication division is spread error much more than addition subtraction. So in addition subtraction, you have a more localized errors on the numbers or variations on the numbers, and they affect that column. But in multiplication, you have this capacity to spread the uncertainty in other decimals is more important than addition subtraction. So it means that looking for the least number of significant figures of the terms is what you're going to do if you mix the operations. So if you add, subtract, multiply, the final result, you go for the least number of sig figs. When you are doing problems, you have your data. So what is this? This is the data of your problem. So you have here, I don't know, 2.3 meters that you are adding, or 5.47 meters. You are dividing this by 17.2, and you keep going. So this is the data of your problem. But just look at your data. You know how many sig figs the result of the problem is going to have, right? So because that math and physics must be very careful. They do not wear so much in the past, the book Knight and Jones, because you need to give to the students very clearly how many sig figs you have exactly in each data, because eventually that is going to affect the final result. What is the best answer for that problem? After do some calculations with those numbers, what is the best answer for that problem? It depends on the number of sig figs of the terms that you use. Okay, but just look at the data of the problem. You have a good idea how many sig figs your result is going to have. Okay. Okay. So what else? We discussed something that is going to be really important for us until the end of this class. Okay. So finally, because we are always operating many times, adding, subtracting, multiplying, I think that the rule for sig figs when you do multiple operations is least number of sig figs of the term. So you look at the data of the problem and say, wow, I have this here, it's 2.3 meters, is only 2 sig figs. I'm going to have to use this in my calculations, so my result cannot have 3 sig figs, right? Because I'm using this data for 2.3 meters is only 2. How am I going to create more digits, more sig figs at the end? No more than what I can, right? So just look at the data of the problem. You have a good idea how many sig figs you're going to have. I can give you an advice that is true most of the time, but sometimes it's not, okay? But when you're going to answer problems in math and physics using 1 or 2 decimals, most of the time it's going to be a good answer. There are a few problems in math and physics that eventually you're going to have too many decimals in your answer, 5, 6 decimals, right? So every time that you use your calculator and you got this number with a bunch of decimals, most of the time they don't make any sense. So don't copy those numbers as a result of the problem and type that in math and physics, because math and physics is going to say, well, it's wrong. You just lose a few points because it does make sense, all those decimals.